Okay, so let's talk about functions, right? Let's talk about functions over here. Let's talk about functions over here. So just like dictionary, we also be doing a lot with functions, right? We'll be doing a lot with functions. So let's get to understand functions, so that when we encounter it, we will actually get to know how it's actually going to be used. Okay, so now if you want to define a function, what you can do is to use this keyword, right? So we use this keyword def, right? And def is nothing but define. It stands for define, right? So it's just a short form of define. So we define the function, right? So we have def, and then the name of the function that you want to define will come, right? So we define the function. So this is just a name that I chose. You can choose any name. So in this case, I use func to represent function, right? So in this case, I could have used just a, or maybe am, right? It's just name that you can use. It's flexible. You can use any name that you want, right? You can define the name as you want. Okay. Now I define my function, right? Then I use my semicolon over here. Okay. Now inside my function, what do I want to do? I just want to print hello from a function. This is what I want to perform inside my function. Okay. So you define your function. You define your function. Then inside the function, you will write the instructions that you want the function to perform, right? Now, if you want to actually make this function work, what you can do is to call the function, right? Is to call the function. If you write the function like this and put the argument in there, it doesn't actually do anything unless you call it, right? So you call the function. When you call the function, that's when it actually works. Now you can see that I have my hello from a function, right? So what I wanted the function to do is to print this hello from a function. So you can see that it's printing that for me, hello from a function. Okay, so you define your function like this, right, with your semicolon. Then inside your function, you write the instructions that you want your function to perform, and then you call the function. Okay, you call the function. All right, now let me move on, and then I'll show you this. All right, so previously in this one, we're just defining the function, right? We just define the function. We use the def keyword to define our function. Then inside there, we just wanted to print hello world. Then later we called our function. What we're going to do over here is to define a function, right? A function called add. As I said, this is just a function name. You can call it anything that you want, depending on what you actually want to do inside a function. As I said, if you want to define any variable name, make sure it makes sense. It's actually relate to what you're doing. Okay, so in this case, I want to perform some addition. So I define a function called add. Then I put in an argument, right? I put in two arguments, a and then b. Okay, don't forget this one, we put nothing in there. So when we call it, we did not call it with any argument. So it's a function with no argument. This is a function with some argument inside. Argument is nothing but I mean, those are variables that later you want to supply, right? So you don't want to supply these values as you define the function, but later on you're going to supply them, right? They are going to be different variables that you're going to supply them, right? So you define, you give that kind of a room, or that kind of a space. You store that kind of a space in the memory so that later on you can provide those values for that. So A is going to be like a container which is going to contain a space in for you, so that later on you can supply a value to go and fit into that space and perform the operation that you want to perform. And then B is also going to create another space or container in there for you, so that it's actually going to help you that later on when you supply any values, it's actually going to contain those values in the memory for you. Okay, now over here I define my function A with these two arguments with my semicolon over there. Okay, what I want to do inside this function is to perform addition. Okay, so I'll add whatever values that I'll provide for A and B. I'll add it and then store it in another variable called C. All right, so C is also going to hold a space. It's going to just be a placeholder, right, in the memory for us, going to hold a place for us, so that later on when we supply our values, it's actually going to supply these values and then perform the operation and store it in the place that it has already held. Okay, so over here is just what we've been seeing over and over again, just printing this, right? So I have print addition of right? Print addition of a. So whatever a value that I'll provide, remember that I'm not putting this in a quote, right? In either a single quote. I'm not putting it in a single quote or a double quote because it's a variable that or an argument that I've supplied here, right? So I just need to call it just like, I just need to put it just like it is, okay? And then n is a string that I want to use, okay? And then the b value and then also the c value, right? So if you can see here, addition, so I'll print this addition of then the value of a. Remember that over here I'm calling the function, right? I told you that if you define your function, for the function to work you need to call it. So the same way I define the function, for the function to work I need to call it. Now I provided a and b to hold a space in the memory for me. Now in that space I'm going to put a as 5 and I'm going to put 10 at the place where b is holding, right? So a will actually go and then will actually go into the memory and then go and then lie at the space where a has occupied for me, and then b will go and then lie at the space where 10 will go and lie at the space where b is occupying for me. Then after that this operation will be performed and then store it in the space where c is occupying for me. Now I'll be able to print them out, right? I'll be able to print them out. So now my a is what, 5, my b is what, 10, okay? And then my c will be 15. That is 5 plus 10, okay? That's 5 plus 10, so I'll be having 15 here. All right, so this one of the different ways that you can create a function with no argument, with some arguments, right? And some of the things that you want to perform inside here, right? Which will vary depending on the program statement that you are working on. Okay, now when you take this, right? Let's try and then see this one. This is over here. I'm trying to calculate the simple interest, right? I'm trying to calculate the simple interest. And I'm defining a function, right? So I'm defining a function called calculate si, so calculate simple interest. So as I said, if you're using this is a variable name that you can choose, right? A function name which is variable. You can choose any function name, define any function name that you want, but make sure that it makes sense to the work that you're doing. Okay, so I'm saying that I'll define a function name called calculate underscore si. That is calculate simple interest, right? And it's simple interest. I will need principal, I will need rate, then I will need time. So this become the argument that I want to put, right? Just like earlier on I was putting a and b, right, in my add function. In this case I'm putting principal, rate, and then time. Now what I want to perform inside that, I have my semicolon here, don't forget. What I want to perform inside this function is to compute the interest, right? And interest here is nothing but principal times rate times time divided by 100. Okay, that's what my interest is. That's what I want to perform inside. Then after that, I just want to return, right? Return the principal plus the interest. That was actually going to give me my simple interest. That's what it's going to, my simple interest is equal to the principal plus interest, right? So that's what I want to return. Now, in order for me to get the output, I need to call my function, right? I need to call my function. So this is my function. I need to call it just like I was doing earlier on, okay? If I go a little bit up, right here, I have my function here. I need to call it, okay? So just like this one too, I defined my function, right? I need to call it. So you define a function. For the function to work, you need to call it. So the same way I define my function here, in order for me to get it, I need to call it. All right. You can call it in a different cell or in the same cell. Earlier on we were doing it in the same cell. Now I'm doing it in a different cell. So you can either do it in the same cell or in a different cell. It all works good. Okay. Now you see that now I have my simple interest over here, right? I have my simple interest over here. Okay. So this an example of a function. Okay. This is an example of a function. So let's move on to loops, right? Let's move on to loops. So we're going to also consider function together with the loops. Okay, we can combine functions together with loops. Now over here you can see that I'm defining my function here, right? So I'm using the def keyword, and then I'm using my function. Now this is very important that you need to take note of. See what I'm doing over here. right? Earlier on, I put some arguments, either principal rate times time, or over here I'm using I'm using a and b, right? Here I'm not even using any argument at all. Now here I'm using some strange argument here, star and then param. What does it mean? What I want to do over here is that I don't actually want to give any limit to my argument that I'm going to supply later on. Remember over here, right? I'm giving a and then b. Now later on, if I call this function and then I forgot that I only gave 2 arguments, right? And then when I'm calling the function, I came and then I gave this 3 arguments. Now if I run this, see what happens. I get an error, right? Add takes 2 positional arguments, but 3 were given. You see how good the error is actually giving me an information of what to do. That's when I defined, I gave 2 positional arguments, but when I was applying the arguments, I gave 3. Now you see that it's pointing to where the error is, right? It's pointing to where the error is. It's not showing that. So C and B is okay, print is okay, but where this happened, where the error happened is here, right? So I need to take care of this part. Okay, see how good Python is. Now this is something that makes this more rigid, right? Because I supplied this argument thing, so which means that I always have to put 2 when I'm calling the function, I need to put 2 arguments in there. If I don't want to get around that, right, what I can do is to use this star and then use any variable name at all. So this param could be say O, or it could be say B, or it could be say M, or it could be anything at all, right? So it's just something that you can use. So I'm just, okay, let me just change param to say MM, right? Let me change it to MM. Anything you can just use, right? So what I'm doing is that for any item in whatever argument that I give, so this one I can give arguments like 2, 3, 4, any argument, 1,000, 10,000, any argument that I want to give, right? So it's more flexible in here, okay? And any argument that I give here is going to work, okay? So now if I run this, right, if I run this, see the argument that I've given here. I've given hi, which is a string. I've given my name. I've given is. Don't forget that I'm calling the function, my function, right? I'm calling it. Okay, I'm calling it over here. So don't forget that. Let me bring my pen so that it will be a bit clear for you. All right, so this is the function over here, right? I'm calling it. Okay, then I'm supplying it with these arguments, these many arguments, 1, 2, 3, 4, right, and then 5, right? But I did not give any 5 arguments here. I just give star and then this mm, right? And then I'm saying that for any p in this so this p is also anything. I could have said any I, or for any value I could have said anything, right? Print it for me. So any argument, so I give this argument, I'll print it out, because that's what I'm saying that they should do. They should print it out, right? For any argument that I give, print it out for me. So you see that it's printing everything. It's printing every argument for me. Okay, so this is more flexible. You can use that so that you not limit yourself to certain number of arguments that you're supposed to provide. Okay, now let's talk about Lambda function. It's also important to actually get to know notes about Lambda function. Now we define a function here, then we give name of the function. What if we don't want to define a function that has having a name, right? So if you want to give an anonymous function, right? So an anonymous function is nothing but a function that is defined without a name, right? So anonymous, right? It's a function without a name. So we use the def keyword to define a function, right? We use the def keyword to define a function, or the normal function. Then we use the lambda function, right? We use the lambda function to actually define anonymous functions. That's a function without a name. Let me show you what I mean by that. Now see what we have here. This is the normal thing that we've been doing, right? We use our keyword here, then we define our function with some argument or without an argument, right? Then whatever we want to perform inside the function, then we call the function. Normally that's what we do. That's what we've been talking about over here, isn't it? Okay, now talking about lambda function, right? Talking about lambda function. Let's see so if we do this, right, we get an output of 5, because we are saying that whatever value that we supply, add 10 to it, right? We get an output of 15 rather. Whatever value that we give, add 10 to it. So we give 5, we add 10 to whatever that we give. We add 10 to the 5, so we get 15. Let's see how we're going to do the same thing over here, right? Let's see how we're going to do the same thing. Now, think of this way. Let me bring my pen so that I can make you understand it clearly. Think of this way. I have my lambda here, right? I have my lambda here. I have this a. Think of this a as the argument that we are supplying here. Okay. Then think of this thing that I've put here. This operation that I want to perform inside the function as the same operation that I have here. You see that I have the semicolon here. Think of it the same thing here. Now I define a function name, right? This way I'm not defining any function name, but I'm storing everything in this variable s. So think of this variable name, this x, as the same thing as what this is doing. So later on, if I do the normal function, I'll call this function. So in this same way, I'll call this x, right? And then I'll supply the arguments, right? So the same way I'm doing here, I'll supply the argument, the same thing that I'm doing here. Okay, then I'm getting the same output. All right, but you see how this single line of code. So you remember when we were dealing with list comprehension, right? How we're able to comprehend the list in a very, comprehensible way. The same thing that we are doing here. Lambda is also helping us to actually compress everything. These functions, we're able to compress everything into this single line of code. Okay, so that's what Lambda is actually going to help us to do. Let me see if I can even find some in the same project that I showed you earlier on, right? So that you see that it's actually important. We're going to use it. Moving on, if you're dealing with your various projects, we are actually going to need now over here. You can see that I'm using Lambda function here, right? You can see that we are using Lambda function here. Okay, so all these that I'm teaching you, something that you're going to encounter in your upcoming classes, in machine learning classes, right? In the project, the various projects that you're going to do, you're going to be encountering them. That's why I'm introducing you to them. Okay, that's why I'm introducing you to them. So take note of them, and when you encounter them later on, they will not become anything new for you. Okay, now over here you can see that we have lambda, right? We have lambda. So think of this m and n as an argument that I could have put in this, right? And then what I want to perform inside the function is this, right? Then I store everything in this x. So it's more like I'm calling this x, then I'm supplying this m and n argument, right, inside there. So if I do that, you see that I have 16, because I'm saying that whatever m that I have, that is whatever m. So here 4 becomes the m, right? 4 here becomes the m, right? So it's going to be 4. Remember that I'm using double star, which means that square, right? So it's more like m n, right? So whatever m that I have, exponent it with the n that I will supply. So in this case I have 4, exponent it with 2, so it's like 4 squared, which is 16. Okay, that's what I'm getting over here. All right, so let's move on here. Now over here I'm combining the function, or the normal way of defining function, with the lambda, right? I'm combining everything together here. So if you see over here, I define my function with a function name, then I supply one argument n. Okay, and then I have my so what I want to do inside this function is to return this lambda c, right? Lambda c, and then c is going to be multiplied with this m. So if n, whatever n that I supply, I multiply it with the c, right? So c is also going to be one other argument, n is also going to be another argument. Okay, now if I call the function here, right, and then I supply in 3, I store it in another variable called results, right? Then I can call results again and then supply another variable, because I have 2 variables here, c and then n. Okay, so I call my function. Remember, when we define a function, we need to call it. So I call it, I supply the arguments in there as 3. So 3 is n. Okay, 3 here represents n. Okay, so I call my function. I have my function here. I call it, I supply the argument as 3, right? So 3 equals n, right? In this case, our n equals 3. Then I store it in another variable called result. Now result here, I'm going to call a result again and supply another argument in here, which is 11, right? So now our c equals 11. Okay, so what is going to happen is that I have c times n, right, which is nothing but 11 times 3, which is going to give us 33. Okay, it's going to give us 33. So if we see the output that we have here, we have 33. Okay, we have 33 here. Now, there are several built-in functions too that we can take advantage. This is user-defined functions. That is function that you define yourself, right? All these we've been doing are all user-defined functions, right? They are functions that we define ourselves. There are some inbuilt functions that we've been touching on earlier on, and now we're going to actually take a critical look at them. Now, we have this variable called a. Then we store this string Google, right? Now, if you want to check the length of Google, we can just count it over here. We can see that we have 1, we have 2, we have 3, we have 4, right? And then we have 5, and then the last one 6. Okay. Now we can actually count it, just eyeballing it. But if this contains a lot of it's a huge data set, we cannot actually just look at it and then count it, right? So what is going to help us to use the length function to see the length of that? Now you see that if we use the length function on the a, you can see that we have 6, right? So depending on the data set size, so if we have about say about 20,000, right? 20,000 different I mean the size of this is actually 20,000. You can use the length to see that. Right, it's actually going to be handy. Let's say we want to convert everything to say uppercase, right? You can use the .upper, right, function to do that. If we do that, you can see that now we have Google to be in uppercase, right? If you want to do it lower too, you can just, I mean, in lowercase, if it is in uppercase like this, you can use .lower, right? That's the lower function. It can convert everything to lowercase. Okay, now we can use print. We've been using print earlier on, so instead of maybe performing the operation then later printing it out, we can print it straight away like this using print and then supply some argument in it and then print it out. Now if we do that, we see what we have over here. We've been able to print it out. Okay, now let's say we have a data set that we don't want to consider the negative part. We want to restrict ourselves to the positive part only. What we can do is to find the absolute value of the value that we have, right? So in that case, we use the ABS. ABS is nothing but absolute value, right? ABS stands for absolute value. So if we perform ABS on this, right? So instead of getting negative 2.14285, blah, 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 we can actually strip off the negative. Now we have 2.142, right? Now we have the positive part. What we can do is to also round this. Maybe we want to round it to 2 decimal place or to 3 decimal place. We can also do that, right? Now if we just do round, this is what we will get. We strip off all the decimal parts and then we get this, right? We can also do let's say I want to run it to say 2 decimal place, right? I can also do that like this and then run it to 2 decimal place. Now you can see that now I have 1.14 there, right? I can run it to say 5 decimal place, right? Now you can see that I have 1, 2, 3, 4, 5, right? I have that. I can also find the minimum of certain items, right? So if I have a minimum of this item, so I have 1,000, 50,000, 57,000, 892. I have 4. I have 89. I have 30,000 and 23. So I can find the minimum of all this. This is a small data that we have here, so we can easily spot that 2 is the minimum. But if this is huge, we can actually easily spot it. So that's why the minimum function is going to come in handy. Okay, so if we do that, we see that 4 is our minimum. It's going to help us to find. We can also do the same thing for max, right? So if we want to find a maximum, we can do that, and if we do that, we see that 57,892 is the maximum over here, right? So if you have a huge data set, you cannot easily see this, but these functions are actually going to help you a lot. Okay, now you might be getting a data set which is quite a mess, right? And you need to clean it over and over again. You might encounter a condition or a situation where you have this kind of spaces over here, which is going to, which is not appropriate. You need to clean this data and make it more, more operational to work with. Okay, so what you can do is to strip off this empty spaces that you have here, and you can use the strip function to actually do that, right? So if we do that, you see that all these spaces have been stripped off for us. Okay, what we can do is that maybe they were collecting the data and there was some typographical error in there, right? So what you can do is to actually correct all these typos, right, that they were doing whilst they were collecting data. So there's a lot of data set that you'll be working with that will come to you. You need to clean them. They will come in a different form of a mess, right? That's why they say that 80% of your time is going to be spent on cleaning the data, right, in cleaning the data. So if a data comes and there were some spelling errors, there were some other things that you need to replace, right, so you can use the replace function to do that. Okay, so in this case we want to replace the r in this with the a, so I use the n. Remember, my n contains this data, this datr, right, so it's supposed to be data, but they wrongly imputed it as datr, right, so I use the replace function to replace the r with a. Okay, so if I do that, you see now I have data. Okay, so now let's come here and then consider this. So we have this G, which contains class, erasers, and then pens, right? Now let's say we want to add this, we want to add pencils. So we have class, erasers, and then pens, right? Now if you want to add another item, right, just like we were dealing with earlier on, we can use the append function to append that. So if I run this, you can see that now we have pencils, right? Earlier on we were not having pencils, but now we've been able to add pencils. So if you have any data, a list of items, then you want to add a new item, use the append function to do that. That's if you want to append at the last end of it, right? If you want to append at the last end of it, you can use the remove function to remove any item that you want. So if I do this, okay, we don't have books in there, so let me do this. We can remove, say, let's say we want to remove pens, right? If I do that, you can see that now. Let's run our G again. Let me run our G again so that we can see again over here. You see that we don't have pens again. We have class, we have erasers, and then pencils. Right? We've been able to remove pens out of it. So remove function also help you to do that, right? We can also use indexing, right? So at index 1, right? So we have 0. We have 0, 1, and then in this case we have this because we removed the pen. So we have 0, 1, and then 2. So at index 1, which is this is 0, 1, and then 2. So at index 1, so we are going to, at index 1, which we have erasers there, we are going to put books there, right? So if we do that, let's see what we have. You see that now we have class, books, and pens. Remember, we've removed pens, so let me just run this. Okay. Now we see that we have class, books, and pencils, right? So we don't have erasers, we have class, books, and pencils in there. Okay, you cannot use that. You can also insert use the insert function. So in order to not replace it, right, so maybe you don't want to replace the erasers, you want the erasers to actually be there, but you still want to put markers in there. You want to put markers in there, but you don't want to replace it, replace any items, but you still want to put it there. You don't want to put it at the end. If you want to put it at the end, then you use the append. But if you don't want to put it at the end, you can just specify at which index. So at index 2, so 0, 1, 2. So at normal circumstance, if we do that, it's going to replace this. But since we don't want to replace that, we are actually going to push this one to index 3, and then at index 2 we put markers there, right? So if we run that, let me actually show you over here. Yeah, let me go a little bit to where we were. Okay, now you can see that we have markers there. Now we did not replace any of them. We have our class, books, and pencils, class, books, and pencils, but in between books and pencils, we've been able to put markers there. Okay, so you can also do it in this way. Okay, now clear is also one of the functions that you need to take. You need to watch out very well. If you use clear, it clears everything that you have, right? So if I run this and then run this, you see that now I have an empty list with nothing inside. Okay, so you need to be careful when you're using clear, because remove is actually going to remove something from it, but clear is going to clear everything. So you need to be very careful when you're using that, right? We've talked about reverse function, where you can reverse this, right? So starting from class to pencils, you can reverse everything to start from pencils to class, right? To start from pencils to class. Okay, so you can also use such function. Now this is just an emoji function that I'm creating. I'm using Unicode. So this is an argument that I'm giving here. If you don't know about the Unicode, I've given you links about every Unicode that you need here. So for the Unicode, if you don't know, you just click on this, you get the Unicode, right? I'm going to use the Unicode here. Now I define a function, right? I define a function called emoji. Then in the function I give an argument Unicode equals none, right? And then I print the Unicode. That's what I want to print. Okay, now over here I call my function. So I'm calling the function several times, right? So first one I call it, I supply in the Unicode. So that, as I said, if you don't know this Unicode, they are just here, right? You just go to this link, you can get them there. Okay, so I supply this Unicode, and then over here I supply this Unicode, then I supply this. All this Unicode represent a certain emoji. So if I print them out, you see that I've been able to print an emoji here. So if you're doing your project, you want to include any emoji inside, you can use this, right? You can use this to do that. Okay, you can use this to do that. Now let's talk about conditional statements, right? So this is where we talk about the if statement, the else statement, the if else statements, right? This is the while statement, the for statement. This is where we talked about it, and then we bring this lesson to an end. Okay, so let's start with the if statement in here. Let's start with the if statement here. So this is the condition that you can give in your project, right? It is a condition that you can give in your project. Okay, now let me see if I have something that I dealt with an if statement, so that you can actually know that this is actually important. Okay, I think even in the Pandas class there's something like that that we can actually do, right? Let me see. Okay, so now if you see over here, right, you can see that I'm using conditional statement here. I'm using for here, right, for I in auto, right? So now you can see that for I in is what I was telling you earlier on. You see that I'm using it over here, right? That I'm using the if statement. So what I want to do is that I wanted to add a tag. So for I greater than or equal to 20, so I'm going into this highway underscore mpg, right, column over here. I'm going into a highway underscore mpg here. If I go in, then I find any value, right? If I find any value, right, so the condition that I'm giving is that if I find any value which is greater than or equal to 20, I give it a tag as big value or big number, right? I give it a tag as big number, so you can see big number. This is greater than 20, so it's giving a tag as big number. All right, so you see how I'm using if and then else here, right? So it's actually going to be helpful, right? So that's why I'm introducing you to it. So for everything that I'm introducing you to it, you're going to need it, right? You're going to need it in your subsequent class, in your subsequent project. Okay, so let's go down to where we are, right? So here we are. Okay, so we have this if statement, right? We have our variable a, which has which is storing a value 7, right? And then b is having value 2. So the condition that I'm giving here is that if b is less than a, then print this for me, right? So obviously if we check b, is b less than a? Yes. 2 is less than 7, right? So it's going to print this b is less than a, right? So if we run it, we have b is less than a as our output. Okay, now over here, right, over here, if we have this, right, this is another condition. So if total in total data sign, so what I'm saying is that if we find this total in this string total data signs, right, print this for me. Yes, you are right, total is in total data sign. So this is just a string that I'm giving that is going to print for me if this condition is true. Okay, so this is an if statement, right? So it's going to compare this with this string and see that if it will find this total in this string, then it will print this for me. And of course you can see that we have total here. Okay, so it's going to print this for me. Okay, that's why you see the output over there, right? That's why you see this output we have. Now let's say this condition, we have a to be 2, we have b to be 7. Okay, now what we're saying is that if b is less than a, right, print this statement for me, b is less than a. Now let's see b is 2, b is 7, right? Now is 7 less than 2? No, it's not less than 2, right? So which means that this condition we have given is not valid. It's not actually satisfying. Okay, so what will happen? Nothing will happen. If you run this, you see that nothing is happening. If I run it several times, it won't do anything, right? Let me just go a little bit here. If I run it several times, it doesn't matter how many times I run it, nothing will be given to me. Okay, it will not output anything. Now what if this condition is not satisfying, but I want to, if this condition is not satisfying, I want to give a different message, right? That whatever condition that I check is not satisfying, so now perform a different action. That's when the if else will come into action. Okay, that's when the if else will come into action. So if we see the same thing here again, so let me just maybe make this one too, so that we can actually relate to the same thing that we are doing here. Now the same thing, right? If b is less than a, the same thing if b is less than a. So we are going to check, is 7 less than 2? No. So if 7 is less than 2, if this condition was right, then this is going to be printed as out for us, that b is less than a, right? If we check the condition is true, then this is going to be printed for us. Now, if this first condition is not true, then this condition will be printed. Okay, so that's what is actually going to happen over here. If what we did with the first condition that we gave is not true, right? So if this condition is not true, then this one will be printed. But if this one is true, then this one will be printed. Okay, so now we have to check, is 7 less than 2? Now it is no, 7 is not less than 2, so this will be ignored. Okay, this will be ignored. Then the else statement will be executed. Okay, so if this is true, print it, else print this for me. So that's the if else statement. Okay, now moving on to this over here. Now I have this. Now you can see that now I'm putting things together for you, right? I'm putting things together for you. Let me put this here. I'm defining a function using the def keyword, right? So I have def continent, right? So my function name is called continent. I provide one argument, which is country, right? So earlier on I was using a, I was using a b, I was using n. So you can give any argument name that you want, right? As I said, if you're giving any variable name, make sure that it makes sense, right? It makes sense and it's relating to what you're doing. In this case, I'm dealing with countries, right? I'm dealing with countries here. That's why I'm using a name called country, right? So just an argument name, but I'm making sure that it's reasonable to what I'm doing. Okay, now the condition that I'm giving here is that if the argument that I gave, which is country, is equivalent, so for Python to measure equivalency, we use the double equal sign, right? So you use the double equal sign, right? So if I use one equal sign, it means that I'm saying that this is equal to this, but I want to make sure that this is equivalent to this, which is two different statements, right? So talking about equivalency, we use double equal sign. Okay, so if whatever country that I've provided is equivalent to whatever is here, right, then I need to return Asia. So if the first condition is true, right, if this is true, I return this. Else, so now you see I have elif, right? Then I have elif. Now in this case, I would have written else, right? Just like I was doing earlier on, I would have written else if, then I gave another condition here. I give another condition here. Then I come again, right? Then I come again, then I write else if, then I give another condition. Then last, that is this one, last I'll come and then I write else, then I give the last condition. So for Python to make things simple for us not to write else if, right? We can be adding a lot of else if. So in between this if and then this else, right? We could have in between these two, right? We could have been written a lot of else if, right? So in between these two, we could have been written a lot of else if in here. Okay, in order to avoid that, right? In order to avoid that, Python gives us the flexibility and the simplicity to combine this else if, right? So instead of writing else if, we write elif. So elif is just as a shortened form or a short form of else if, right? It's just a short form of else if. Okay, so elif is just a short form of elif. Elif is just a short form of else if. Okay, so in order to avoid writing else if, we can just use elif, right? So this is one of the good things about Python, right? Not to actually complicate things for yourself, to be writing else, right? Else if, you just write elif and you're good to go. Okay, so that's one of the good things. Now over here, I check the first condition. Is the country equivalent to India? Yes, print Asia for me. Right, so in this case, remember this is my function. I call the function. Then I supply the argument, which is country. So I supply the country, I supply India. So now Python will check, is this India equivalent to this India? Yes, so I will print Asia. You see that now I have Asia here. Okay, now let me show you the next one here, right? Let me show you what is output here. So now we have this in here. if we call the function again, right? If we call the function again, and then inside the function we supply South Africa, what Python will do is that it could compare South Africa with India. Is South Africa equivalent to India? No. It will move on to the second one. Is South Africa equivalent to Germany? No. It will move on to the third one. Is South Africa equivalent to South Africa? Yes. Then it will output Africa, right? So if we see the output of this, right? Let me do this. Okay. If we see the output of this, you see that we have Africa here. Okay, so it will compare it with each of them, then it will output. If it didn't find anything, it will output none. Okay, that's what is actually going to happen. Like nothing will be the result. That's what it's saying. Output, return none. So we will get nothing. Okay, if no condition is satisfied. Now let's talk about the while statement. Right, let's talk about the while statement. Now what the while statement is going to help us to do is that it's actually going to be executed repeatedly, right? So repeatedly executing a block of statement for as long as the given condition is true. What does it mean? What it means is that we are going to give a certain condition. So far as this condition is true, this code will keep on executing and executing and executing and executing. Okay, so if you see this one that we have here, I'm creating a variable called number. I'm initializing it with a variable name. With a value code. With a value of 10. Okay, I create a variable with a name of number. Then I assign it with a value 10. Okay. Now, while the number that I created, so while 10 is greater than 0, right? That is, while 10 is greater than 0, right? We keep on executing that, right? And then we keep on reducing 10 by 1. That's what is actually happening here. We keep on reducing 10 by 1. Then we print the output. So if we do that, let's see what we have here. So what it will do is that it will first start with 10, right? It will first start with 10. It will first start with 10, right? So let me bring my pen so that you can see. It will first start with 10. And then check, let me do this. Okay, it will first start with 10, okay? And then check, is 10 greater than 0? Yes. Then it will reduce 10 by 1, right? It will reduce 10 by 1 and then print it out. So 10 minus 1 is 9. Now it will check, is 9 greater than 0? Yes. Reduce 9 by 1, it will give you 8, right? Then it will print it out. Is 8 greater than 0? Yes. Reduce 8 by 1, it is 7, right? Then it will print it out. Is 7 greater than 0? Yes. Reduce 7 by 1, then print it out. So that will give you 6, right? Then it will check again, is 6 greater than 0? Yes. Reduce 6 by 1, that is 5, okay? So if you do the same till it gets to 0, so it's 0 greater than 0, no, then this condition will be violated, right? So this condition will no more work, and then we will stop over there. So far as this condition is true, it will keep on executing until it becomes false. Okay, so that's the while statement for you. That's the while statement for you. Now let's consider this. Let's consider this over here. All right. So I have, let me give you the output so that it will actually make sense to you. Okay, now I have this variable, initializing it with a value 1. Okay. Now, while this condition is true, while the value is less than or equal to 10, keep on printing the value and keep on increasing it with 1, right? Else print this, right? So as soon as it becomes false, print this for us. Okay, now I'm using while and then else, right? I'm using while and then else together. So I have this initialized to 1 that I'm going to use. This is the condition that I want to check. This is the condition that I want to check. So far as this condition is true, it will continue executing, right? It will continue executing, right? Until it becomes false, then it will start executing this. Okay, so now if it will check, is 1 less than or equal to 10? Yes. Then print it out. So I'll print 1. Then increase 1 by 1, which is 2. Which is 2, right? Then it will check, is 2 less than or equal to 10? Yes. Print 2 out. And then increase 2 by 1, so you have 3, right? Is 3 less than or equal to 10? Yes. Increase 3 by 1, that will give you 4, right? And print it out. And then it will do the same thing till it gets to 10, right? Now when it gets to 10, is 10 less than or equal to 11? right? It's true, 10 is equal to 10, right? It's not less than 10, but it's equal to 10, so it still satisfies the equation, so it will print it out, right? It will print it out, and then it will increase 10 by 1. That will give you 11. Now it will check again. Is 11 less than or equal to 10? No, that's false, right? Then it will print this statement. It will print that statement, and then remember that my I is here, so the I is now 11, right? Which did not satisfy the equation, so it will print that for you. Okay. So let's move on and then see this one here. Let's see this example also here. Okay, so I have this variable. I have it stored in this this string, total data science, right? Then I have this j initialized with 1. So what I'm going to do is that while this j, right, which starts from 1, is greater than 0, right? So while this one is greater than 0, right, I'm giving another for here. So you see that I'm combining while and then for and then if, right? And then I have a break here. So you see what I'm doing over here. So I have j, I have here, right? So this is the condition here. This is the condition here. While the j is greater than 0, for I for x in I. So for any item, this I contains this. For any item in this total data science, right? Print the j and then the x, right? What it's actually doing over here is that let me output this. What it's actually doing over here is that if it will use this one to check this condition, so it's 1 greater than 0, yes, right? Then it will print that one. It will print that one for you, so you see that you have the one here. Then for x in I, so for x also in I, for x in this I, and I contains this. Okay, so for that, print that x also. So the x is actually t, so that's the first item. Don't forget x in I means that for any item in this, for t o t a l d a t a s c i e n c e. So for any item in that, x is going to represent that. So it will print j, and then it will print x also for me. So it's going to print two things at the same time for me. Okay, then to keep on increasing the j, don't forget j starts with 1. So as soon as as far as j is greater than 0, so j equals 2 is greater than 0, right? It will keep on printing the j and then adding the x for us. So if print the first j, which is 1, it will print the first letter. If it prints the second j, it will print the second letter. If you print the third j, it will print the third letter. If you print the fourth j, it will print the fourth letter. If you print the fifth j, it will print the fifth letter. If you print the sixth j, it will print the sixth letter. That's what's actually happening inside here, right? That's what this part is actually doing. Print the j and then print the x, right? And then keep on increasing the j. So it will start with 1, increasing it to 2, increasing it to 3, increasing it to 4, all the way till the condition is up to the last one that we are breaking it, right? So it will keep on increasing it up to the last e that we are giving a break over there, right? If x is equivalent to this e, then we'll break it. Okay, then we break it. Otherwise, so far as this j is greater than 0, so this one can go all the way to say 1000, right? Because 1000 is greater than 0. So we keep on doing it. 2000, right? 2000 is greater than 0. Keep on doing it. It's going to actually keeping on executing this so far as this j is greater than this 0, right? That's why we are giving a break here, right? That's why we're giving a break over there. All right. So I have some small assignment here for you, which just to find the difference between the while and the if statement. Remember, we've dealt with the while, then we've dealt with the if statement, right? The for, so you can just find the difference in between them, then just get yourself familiar with that. Okay. Now, the for statement. I mean, we've been talking about for statement throughout, so I think this is quite okay for you. So for any item in this, means that for any this item, I'm going to print it out. If I do that, you see that I'll print 100, 200, 500, 1000, 4000, 5.5. Okay, so this is something that we've been dealing with, which you are quite familiar with. So I'm not going to spend time on that again. It's just the same thing, right? It's just the same thing. Maybe this one, right? Maybe this one. So over here, I'm saying that names. I'm giving a list here. this is my names list, right? So I'm saying that for name in names, right? So for any name which I'll find here, then I'm going to check this condition, right? If the name is equivalent to this, right? If the name is equivalent to this, so I'll go through this. As soon as I encounter this, this is what I want to print. No spams here, right? Because this looks like a spam name, right? I have Cimarron, I have this name I cannot even pronounce, I have Plateau, I have Share here. So these are, I mean, if you see, let me do this. If you see these ones, right, these ones look like real names, right? But this one looks like a spammy name. Okay, so I'll go through. So that's for any item here. I'll go through each of them. As soon as I encounter this, I'll print this statement, right? No spam names here. Otherwise, I'll continue, right? I'll continue. So I use continue here. I'll continue. Then I'll print this looks real, right? So it will print everything. So this looks real. As it encounters the first name run, it will print this looks real. I'm using plus the name, so it will print the name out. So that's what it's outputting here. Then as soon as I encounter second one, it's going to print no spam here, right? Because now the condition here is satisfying, so it will print this. Right, now it will continue after that, right? It will continue after that. Then it will encounter this, which, I mean, this looks real Plateau, right? And then it will encounter this looks real Share, right? Now, if nothing else is in there, then print this, right? Thanks for removing spam names. You see that's printing that. Thanks for removing spam names. Okay, so basically that is it. That is how you can actually remove it. This is something that we've dealt with earlier on. I don't want to repeat it. As we've dealt with this, right? Where we have the square in this range, right? So let me see if there's okay. There's just the output. Okay, so I hope now you have a basic understanding of Python. You have the basis of Python, and you can actually move on to the various libraries, right? So in the next class, we're going to start talking about the various libraries in the likes of Numpy, Pandas, Matplotlib, Seaborn, and all the other libraries that we need in the machine learning class, like the SciPy and the other libraries. We'll be taking all of them one by one, and we'll be dealing with them. Okay. We'll also be doing some web scraping later on. All right. So this is just the basics for you. Okay. So I hope you have an intuition of what we are going to do with it. And I mean, this is purely project based, as I said earlier on. So we're going to be doing a lot of projects, right? A lot of projects. So thank you for staying tuned in. I mean, keep practicing, keep learning. We'll meet in the next class. Bye bye.